If I told you that x equals 5, that's pretty simple. X is that specific value. But what if I said that x was greater than 5? It could be anything that was larger than 5. 5 and a half, 5 and 3/4, 6, 10, 100, 1,000. Any number that's larger than 5 would meet that criteria. Today we're going to talk about inequalities and how to write sets using inequalities. The first thing you need to know is some notation. The notation is right here. Greater than and less than. You should be able to identify those two symbols and know exactly what they mean. If there's a line under it, which is like a part of an equal sign, it means greater than or equal to or less than or equal to. For instance, if I said x was greater than 5, it would be any number bigger than 5. If I said x was greater than or equal to 5, it could be any number that was 5 or bigger, including 5. When you graph these on a number line, it's important to know that sometimes the point that you draw is going to be a filled-in circle or an open circle. If it's greater than or less than, it's an open circle because it does not include the value where you put the point. If it's greater than or equal to or less than or equal to, it does include that point, and therefore it'll be a filled-in circle. Let's take a look at a couple of examples that'll make that a little more clear. On these 4 examples, they gave us an inequality and asked us to graph it on the number line. Here they said x is greater than 5. Greater than is an open circle. It does not include 5. And so on the number line, I put an open circle at 5. Now I want to go greater. Which way is greater? Well, 6, 7, 8, 9, 10 going this way is greater. And so I shade that in, and I put an arrow in at the end of the shading because that will go on forever. On example 2, it says less than or equal to 7. So x is less than or equal to 7, which means because it can be equal to 7, I'll put a closed circle on the 7, and less than goes this way. And so I shade in the number line going this way. You should always shade in so it's dark enough so that a reader can see your shading, or use another color. Down here we have x is less than 37/4. I wasn't quite sure what 37/4 was, so I converted it to a mixed number. It's 9 1/4. I drew my number line. 9 1/4 is about right there. Open circle because it's just less than, and I shade in to the left, less than. Now because it wasn't the circle, the hole is right on between two numbers, it's between the 9 and the 10, it's a good idea to write what that value is. I wrote the 37/4 right above it so that folks who were looking at it could tell that that was 9 1/4. Finally, on example 4, we have x is greater than or equal to 3/2. 3/2 is 1 1/2. So I did the same thing. I drew my number line, and at 1 1/2 I put my closed circle because it says greater than or equal to. Then greater than, I go to the right. I was sure to label that because it was between 2 points on the graph. I wanted to be sure that my readers knew exactly what I had put for a point. Sometimes they'll do the opposite. Sometimes they'll give you a graph and say write the inequality. These are 2 different ways of writing the same thing. This means the same exact thing as this. This means the same exact thing as this. So if they give you this, you could easily rewrite it so it looked like that. And if they gave you that, you could easily rewrite it so it looked like that. You're just translating back and forth. It's like 2 different languages, but they mean the same thing. Examples 5, 6, 7, and 8, they gave you the graph. And they said write the inequality. So we're translating. So I looked here and I said, okay, there's a closed circle at -5. And it's going to the right. It's where numbers are greater than -5. Because it's a closed circle, x is greater than or equal to -5. On example 6, there's an open circle at the -10, so it does not include -10. And then it shades to the right. X is greater than or equal to, not equal to, x is greater than -10. This is larger, we're going off to the right. Down here, we have a closed circle at -2, and then we shade to the left. X is less than or equal to -2. Finally, we have number 8 here. There's an open circle at 6, meaning it is not included, and we're shading to the left where it's less than. So x is less than 6. These are basic inequalities. Now, sometimes you can have inequalities that have more than one criteria. Let's take a look at those. When we have more than one inequality that we're dealing with at the same time, we call that a compound inequality. When we're dealing with compound inequalities, we're using things called unions and intersections, just like we did before when we looked at the set notation. In this example, we have two things. We have x is greater than -3 and x is less than or equal to 5. And I have in the middle here an intersection. And another word for intersection is and. And means intersection. So the first thing I'll do is actually graph both of these inequalities. The first one, x is greater than -3. So I have an open circle at -3, and it shades off to the right. You can see that in red. The second one is x is less than or equal to 5. That's a closed circle at 5, and the shading would go off to the left. Because I want the intersection, I want the part that they have in common. The part that they have in common is the part that's shaded both red and blue. That's the area between the -3 and the 5, and so I've shaded that in with purple. That's how I work with a compound inequality. On the next example, examples 2 and 3, are a couple for you to try. Please pause here, see if you can graph those two inequalities, and let's see how you do. Let's take a look at the answers to those inequalities. On example 2, we have x is greater than 3, intersected with x is less than or equal to 9. Open circle at 3, shading greater than, closed circle at 9, shading less than. Intersection, I want the part that is covered by both of those two inequalities, both the green and the red. So I've shaded that in purple. It's in between those 2 points. On example 3, I have x is greater than 7 with the intersection x is less than 4. I've shaded both of those inequalities, and I found the intersection, that's the area in between. And that's what the set looks like as an inequality, written on the number line. Now the second part of that question says, if set B is -7, -3, 2, and 4, is B a subset of A? Well, let's see. -7 is in there, -3 is in there, 2 is in there, 4 is not. 4 is an open circle. 4 is not included in that set. Therefore, set B is not a subset of this set. Now, let's look at the other possibility. We just looked at intersection. Let's look at the union. Another word for union is the word or. So if you see the word or, you might want to think, oh, they're asking me to find the union. Here's an example. We have x is less than or equal to -3, x is greater than or equal to 5. Now, let's begin by graphing each of those inequalities. X is less than or equal to -3, we have right here. X is greater than or equal to 5, we have right there. Now, when we have the union of two sets, we bring the sets together. It's everything. We just merge it together. And so when we have the union, we have all of this, and we have all of this. We just take it all and put it into one set. And therefore, this here is what the graphed inequality looks like for this union. We simply have x is less than -3 combined with x is greater than or equal to 5. Let's see if you can do these. The next two examples ask you to graph a couple of unions. Let's see if you can do that. Please pause here and give those examples a try. Let's see how you did. Example 6, we have x is less than or equal to 0. I've done that in red. X is greater than 3. I've done that in green. They asked me to find the union. Union means everything all together, and therefore there is the number line of that set. Example 7, x is less than 2. I've graphed that in red. X is greater than or equal to 5. I've graphed that in green. It's the union, it's everything together, and so that's my answer. That's the graph of this set, this inequality. The last part of this question says that if B, the next set, is all of the numbers greater than 7, is B a subset of this? Well, let's find out. B would be all numbers larger than 7. That would be everything going this way starting at 7. Notice that everything there happens to be covered by the green graph. Therefore, all the numbers larger than 7 are in this first set. The superset has all the numbers larger than 7. So B must be a subset of A. Those are the basics of working with inequalities, graphing them. Simple inequalities where you have x is greater than 5, or compound inequalities where you have unions and intersections.